Welcome back. In today's programming adventure, I'm going to pick up where we left off in part 1. Last time, we made a simulation of a ball bouncing around inside an HTML canvas. In this video, we're going to finish up our game of Pong, and I'm going to show you the amazing power of vectors, which you can think of as just arrows. I'm not going to fully explain vectors here. Instead, this is going to be more of a visual explanation of what vector math looks like, so that you can build some intuition about it. Hopefully, while we build the collision rules to bounce the ball off the paddles, you'll see why vectors are so useful. Anyways, let's just dive right back into programming. So, first things first, we want to figure out how to use vector math to get really nice collisions off of these, off of the paddles. So, we need to decide how we're going to code a paddle. And what we're going to do is we're basically just going to say that a paddle, the hit area is a line between 2 points. And if we can figure out how a ball can ricochet off of a line, we're good to go. We can just use that solution and it'll look pretty good. So first things first, we need to draw a line. And in order to create a line, you need 2 points. And we can actually use vectors for those 2 points. So let's do that right now. I'm going to say point 1 equals, let's say a vector at, who knows, I'm just going to make it up, 400 and 450, and then point 2, let's say 300 and 400, something like that. So we don't have a way to draw these points, but there's a little helper function in the vector library that lets you draw vectors to a canvas. So let's do a temporary function. I'm just going to call this test because we're going to delete it later. And I'm going to call this in our draw function test. Okay, so if I say point 1 dot debug draw and give it the canvas context, it'll draw that vector from 0, 0. And let's stop this ball from moving around. So comment out move circle. And let's do the same thing for point 2. So we have 2 points here, and we're representing those points as vectors. So it's drawing a vector from 0, 0 to each of these points. And in order to draw the line between those 2 points, we want to draw the vector from one point to the other at this point. So first we need to get that line vector. So let's say let line vector equals, and the way to do that is say point 2 dot minus point 1. So the line vector is going to be the second point minus the first point. And if we draw that vector in the same way, debug draw ctx, we don't see it here. And the reason we don't see it is because it's actually being drawn over here, and I think these other 2 vectors are getting in the way. It's drawing this vector, this line vector, from 0, 0. we can actually override that and tell the debug draw to draw the line vector from point 1. And if we do that, we actually have the line vector being drawn from point 1, which is over here. So let's actually just get rid of these two. So now we have a line, and that's going to come in really handy, because if we can figure out how to bounce this ball off of this line, then we can just use lines for paddles. So what we want to do is we want to find out the distance from this, the center of this ball, to this line. And I'm actually going to just set up something here to let us move this ball with the mouse. And the way I'm going to do that is say window.add event listener and do something really quick and dirty. And I'm going to say ball.position.x equals e.page x, and ball.position.y equals e.page y. So now when I move my mouse, the ball should roughly track my mouse. This is just for testing purposes. So if I have this ball over here, the shortest distance from this ball to that line should be the distance from the center here to the tip of this vector. If I have it on this side, it should be the distance from the center of the ball to this other side of the vector, this other vertex. But if I have it somewhere in between, it's going to be the line from the center of the circle to some place in between these 2 points. And it's going to be the perpendicular distance. So we need to figure out how to get a vector that is going to draw this shortest distance to this line. I'm just going to quickly fix this. I would like to run my test function after I draw the circle so that I can still see the vector drawn on top of the circle. That's a little bit nicer. So the first thing I'm going to do is I'm going to draw a vector from the starting point of this line to the ball. So let's go ahead and do that. The way to do that is we're going to do point 1 to ball equals ball.position.minus 0.1. And we're going to debug draw that. CTX. Oh, I need to draw it from point 1. Point 1, there we go. Let's actually add different colors for these vectors so that we can keep track of them a little bit more easily. And the way to do that is we can give the debug draw command some other parameters. And the order it goes in is we can give it a scale, and the scale would increase or decrease the size, the scale size to draw the vector. That's not really useful right now, so we'll give it a scale of 1 so that nothing changes. We can tell it to draw the components of the vector, the x and y components of the vector. Again, we don't need that right now, so I'll just say false. And then we can give it a color. Let's give it a color of gold. All right, so now we have a different color for this vector. The next thing I'm going to do is introduce you to the idea of a projection, a vector projection. And it's kind of like a shadow, the shadow of one vector onto another. the way to, I think the best explanation is just to show you by drawing the projection of that vector. So the way to do that is to say, let projection equal point 1 to ball, and project it onto the line vector. And then we're going to draw that projection vector in the same way. Proj. Let's give it a color of, let's say, aqua. That's pretty nice. Okay, so you can see that it's almost like we're casting a shadow of the yellow vector onto the line vector, the white line vector. And the blue vector is this shadow. It's the vector projection of yellow onto white. So this projection vector actually helps us in finding the perpendicular distance from the ball to the line. It's going to be where the blue arrow stops, where the blue arrow points to along this line. The problem is that it goes beyond the boundaries of this line. So ideally, we'd want this to stop once it gets too far here. We want it to be bounded within this white line, this white vector. The way to do that is I've got a little helper function in here, and instead of getting the projection, I can get the clamped projection. Clamp is a common programming term that says you want to bound some value between something and something else. So clamped projection, and that should clamp it to the size of the line vector. This is really useful because if we now take this blue vector, this aqua vector, and draw an arrow from the tip of the blue vector to the center of the circle, we actually have the displacement vector for the shortest distance, the shortest displacement between the ball and the line. So the way to do that is to subtract one from the other. So I'm going to do yellow minus blue, which ends up being, so we'll call this displacement equals the yellow vector, which is 0.12 ball, minus, subtract the projection vector, the blue aqua vector. So let's draw that displacement vector. So we'll do displacement dot, let's just copy all of this because we want it to be drawn almost in the same place. But let's actually just draw this displacement vector in tomato red. And instead of drawing it from 0.1, let's draw it from 0.1 plus projection. That just moves it all the way over to the tip of the blue arrow. So now we can see we have a displacement vector that is the shortest displacement between the ball and the line. And that it doesn't depend on what the line is. It doesn't depend on where the ball is. It just always gives the right answer. So I find this so satisfying, especially in these pretty colors. And we've actually just figured out how to detect a collision, because all we need to do is use this red vector, and we can check how long it is. And if the length of the red vector is less than or equal to the radius of the ball, then that means the ball is touching this the line. Not only that, but it also gives the direction of the normal along which we would reflect the ball's velocity. So we can just make up a function that reflects this ball off of any line we want. So let's do that function right now. Let's make a function called line bounce. So what we should do is we should use this function first. So where we want to use it is after the check edge bounce. We should check line bounce. And I can make a check line bounce function. Actually, I'll move that all the way up here. And the check line bounce function should do a line bounce, and we should give it a line. So let's set this line to an array, and it'll hold the 2 points for the line. So point 1, point 2, and we'll pass in the line. But let's also pass in the ball's position. Actually, we can just pass in the entire ball. So we have a line that's an array and the ball. We can copy all of our hard work here and just take away the debug draws. Actually, we could leave them in. Let's just clean it up a little bit. We'll move all of this down. And so this will be where we draw the vectors as a little test. We should set point 1 equal to line 0, point 2 equal to line 1, and we already have ball position. So this looks pretty good. And now we have the displacement. So what we should do now is use that displacement to collide, to check to see if the ball collides. So we need to say if displacement, and actually let's set up a variable. Let's say the distance is less than or equal to the ball radius. That's when we have a bounce. So to get the distance, we take the displacement and we're going to say we want the norm of the vector. So that's the magnitude of the vector, the length of the arrow. So this distance, if it's less than the ball radius, we have a bounce. And if we have a bounce, we need to reflect the velocity using the displacement vector as the normal vector of the reflection. And there's an easy way to do that. We can use the vector library and we can say ball.velocity.reflect, and we just need to give it the normal vector displacement. So that should work. Whether or not it does is going to be revealed once we start animating. Let's move this ball a little bit upwards to start and animate the ball. We need to uncomment move circle. Oh, that looked pretty good. Let's see if we can get it to bounce off of one of the vertices, one of the edges of this line. Oh, not too bad. So I think that's working. Yeah, there we go. It's pretty good. Something we can do to make it a little bit better is to notice that depending on the frame rate, the ball might actually overlap with the line. And sometimes this can this can create some weird effects. So to make sure that it ricochets really cleanly, we can do something a little bit clever, and we can just move the ball so that it's not touching the line anymore. So when we get a bounce, we not only want to reflect the velocity, but we also want to just nudge the ball ever so slightly so that it doesn't get caught inside of the line. And the way to do that is we can say ball.position, and we can add some tiny amount equal to the overlap. So what we do to get the overlap is take the ball radius and subtract the distance. So if we have an overlap, this number should be positive. And all we need to do is shift the ball along the displacement vector by this overlap. So what we can do is we don't need our displacement vector intact anymore. We can modify it and say displacement dot set norm. So set the magnitude, and we're going to set it to the overlap. And then we can just add the displacement. And that should give us really clean ricochets. So if I speed this ball up a little bit, increase the velocity. Oh, that's so satisfying. That's looking really good. All right, we have everything we need to start making the paddles to hit the ball for our game of Pong. Let's see what we can clean up. I think we can delete this test code, and we should delete that test function call. And for some reason now, our lines aren't getting drawn. Oh, that's because it's drawing these when we call line bounce, but line bounce is actually being called right before draw, and draw clears the canvas immediately. So that's why our lines aren't getting drawn anymore. If we really want to see them, we can move the clear canvas call. But for now, this is okay. So the next thing to do is we need to create paddles. So in order to create paddles, we need to basically just draw some rectangles. We're going to need to hook that up to the keyboard so that the rectangles move if you press certain keys on the keyboard. And then we need to tell the paddle to check whether or not the ball is intersecting with its hit line, and then reflect the ball if that happens. So we need to specify whether or not it's got a hit line on the left-hand side or the right-hand side. So I'm going to imagine again that I have a function that creates paddles, and I'm going to call these paddles player 1 and player 2. So let's just create player 1 first, and I'm going to imagine I have a function called create paddle. What I'm going to do is I'm going to pass it an x position, and let's set it to 50 for now. And I'm going to give it a width. And let's say, I don't know, 20, height, 80 maybe. I don't know, I'm making this up. And that should be enough to draw a rectangle. Maybe I should give it an initial y position, because the y is going to change depending on the keyboard, but we can tell it where to start it at least. I don't know, 100. Let's make it up. So that should create a paddle, and we could do the same thing for player 2. But player 2 should be on the other side, so we should say the x is at width minus 50. So we're going 50 from the other edge. And player 1 and player 2, we're going to want them to move themselves and draw themselves. So we're going to go down to where we call move circle, and we're going to say player 1 dot check move and player 2 dot check move. And I'm calling it check move because we're going to check if the keyboard is actually getting any keys pressed, and only move it if that's the case. And then in our draw, we need to say player 1 dot draw, and we'll pass it the canvas context so that it knows how to draw it. And same thing with player 2. So that's how I'd like to use this. Now I'm going to create this create paddle function. And I'm going to create a new file for this, and I'm going to call it paddle. And I don't need to say JS, it does that automatically. And I'm going to drag it above script because I want it to run before script runs so that we can use the create paddle function in the script.js file. So if we go into this new file, it's totally empty. And we can now create our function called create paddle. And it takes in an object, and the way the shortcut for this is to use these curly brackets here and say we're taking in an x, a y naught, a width, and a height. And so that's our input for this function. And we know we're going to be returning some kind of object. And this object is going to have a check move function, and it's going to have a draw function. So this is shorthand for assigning these functions to this object. I need to actually create those functions. So draw should be the simplest to do and should give us some payoff first. So let's just comment out this check move for now. The draw command takes in a canvas context, and we want it to draw a rectangle with a certain width and a certain height. So let's just do that now. ctx.fill rect, and we say x, why not, width, height, and that should be drawing our paddles, but it looks like we have some kind of error. And if we have an error, I can click this button up here to bring up, and it says check move is not a function. Okay, so I should just add an empty function that doesn't do anything for now. Nice. Okay, so we've got it drawing two rectangles on either side of the board. But something to note, first of all, they're both red, and second, they look a little bit offset. And that's because the way we draw rectangles, it goes from the top left corner, and we draw it by the width and height we specify. So if we want the position XY to be in the middle of this rectangle, which is way easier to keep track of, we are going to need to draw this a little bit differently. And the way we can do that is say x minus width over 2. And I'm going to try to keep this as neat as possible. And y naught minus height over 2. So now we're drawing rectangles with xy being the center of the rectangle. So that's going to be a lot nicer to keep track of. The next thing we should do is we should create a y that can change, and we'll first set it to whatever the y naught is. But we're going to use this y as the position of the paddle, and we're going to let that change depending on the keyboard, what the keyboard does. So what we need to do now is change the color of these paddles. So before we do fill rect, I should set a color. Fill color equals, let's just make them white for now. Oh, it's not fill color, it's fill style. Perfect. Okay. So now we need to move the paddles depending on what keys are pressed. The way to hook up the keyboard is to say window dot add event listener, and we listen to key down, the key down event, and we provide a function. So the key that's pressed is e.key. You could also use key code, but I like to use key so that I can write it as the name of the key. So I would like to actually specify which keys are going to move it up and down. So I should go back into my main script, and player 1, I'm going to say the up key is W, and the down key is S. And for player 2, the up key should be arrow up. That's what the cursor arrows are called. So the down key should be arrow down. So we have a specification of which arrows or which keys control which paddle. And I can say up key in here and down key. And let's test to see this works. So if key equals, it's the same as up key, then we want to move it up. So let's just say y equals y plus 10. Let's just do that for now. Else, y equals, I should do an else if key equals down key, then y equals y minus 10. So if I click in here and use s, oh, I've mixed up the sign because up is negative, down is positive. I forget that sometimes, and I've been coding for 10 years. So just goes to show you, sometimes the standards are a little confusing. So if I press the S key, it moves down, and I can move it up. And if I use the arrows, perfect. Nice. And I can do both at the same time. Looking good. So at least we know that the keyboard is working now, but this isn't the nicest sort of interaction. It would be way nicer to make this smooth, a smooth up and down. And we already have an animation loop to draw smooth animations. So we should use that. We can do something really similar to what we did for the ball. We can assign a velocity for these paddles. And if the down key is being pressed, then we set the velocity to move it down. So we set a positive velocity. And if the up key is being pressed, we set a negative velocity in the y direction. So what we can do is let velocity equal 0. And we'll just use a single number. So now instead of changing the position, what we should do is we should change the velocity. So we can just say velocity equals up is negative. So let's say minus 0.5. I'm just making it up. And if it's the other direction, it's going to be 0.5. Okay, so now this is where the check move comes in handy. And actually, we can just say y equals y plus velocity times dt. And we don't have dt. I should give it to this function. And we actually don't need this check move on second thought. We can, or we don't need to call it check move. We can just call it move. And it'll take dt. And we need to go back and change our call in here. So player 1, I'm going to call these both just move, and I'm going to give them both dt. So if our paddle has a velocity, it should change the y variable, and that should draw it at a different place. So let's click in here and see. Ooh, that looks pretty good. That looks way smoother, but now the paddles are moving even when I let go of the keys. And that's because we didn't plug into a key up event, which is when we let go of a key. We should set the velocity to be 0 so that it stops moving. So we can copy this line at least and listen for a key up event. And let key equals e.key. And I'm actually going to copy this if statement because this is actually listening to every single key up event. So if we're we've got two people on the keyboard and they're pressing different keys at different times, we don't want a key up event from player 2 to affect player 1. So we need to check that they're the right keys. So I need to say velocity equals 0, and same thing for the down key. And this is a little bit redundant, so let's actually just consolidate this and say, or key equals key down. And that should do the same thing. So if the key that's being let go of is either the up key or the down key, we need to set the velocity to be 0. So let's give that a try. Nice. That's working really well. The only last thing about this, these controls, is they can go off screen, which that could get pretty confusing. So we need to stop them before they get to the edge of the screen. And the way to do that is give it a minimum Y and a maximum Y. And that'll be the boundary between which the paddle should stay. So if we go back into our main script file, we can say that for both paddles, the min Y should be, let's say something like 100. Let's start with that, and we'll say the max Y should be height minus 100. And we'll copy that for both. And now we just need to use these two variables to restrict the Y position of the paddles. And there's an easy way to do this, and it's using what are called min and max functions. So if I write math.min and I give two numbers here, then this function is going to return the smaller of the two numbers. So I can say, give it Y and max Y, and if Y is bigger than max Y, it'll just return the max Y. So I can say Y equals either itself or the maximum if Y is too big. I can do the same thing and say math.max Y and min Y. So this returns whichever is bigger. So if Y is smaller than the minimum Y, it's going to return the minimum Y because it's the bigger one. And that should be enough to restrict the paddles. So let's give that a try. Perfect. So now the paddles can't go beyond the boundaries. And I think these boundaries are a little bit too big. So let's go back into the script file, and I'm going to select 100, 100, and I'm going to change that to, what's the height of the paddle? 80? Let's say 50. And we'll copy, paste, and let's try it again. Yeah, it comes almost right to the top. So that's looking pretty good. Let's just tweak these values a little bit. You can tweak this as you see fit, of course. Just play around. If you want giant paddles or really tiny ones, go ahead and put your own values in here. I'm going to stick with these values. So now we need to bounce this ball off of these paddles. So we need a function that checks whether or not the ball is intersecting the line for each of these paddles, the hit line. So for the left paddle, the hit line should be on the right-hand side, and for the right paddle, it should be on the left-hand side. So let's tell this create paddle function which side the hit line should be on. So let's say hit side is right for player 1, and hit side, oh, I said size, I meant side, is left for player 2. Okay. There's been this mystery invisible line that the ball is bouncing off of. Let's remove that for a second. So let's actually delete this. I'm gonna clean up all of this test code that we had. We don't need this anymore. I'm gonna copy the line bounce function, and I'm gonna delete those. And in our paddle.js, I am going to paste in this line bounce function. So what we need is we need the ball and we need the line points. What we should do is next to our check edge bounce call down here, we should do a player 1.check hit, and we'll pass it in the ball. Player 2.check hit, and pass it in the ball. And just for good measure, let's just move this circle command all the way to the bottom. So it's going to check whether or not the paddle moves. Then it'll check if the ball bounces off the edges. Then it'll check if it hits the paddles, one of the paddles, and then it will move the circle accordingly. It doesn't really matter which order we do these things at this point, but it's nice. It just makes sense to me in this order. So we need a check hit function check hit, and it gets the ball. It's not doing anything at the moment. But what we're going to want to do, we can just start writing this as if we know what we're doing. We need to call our line bounce function, and we want to give it the hit line, whatever that is, of our paddle, and pass it the ball. And if we can get the hit line, this should just take care of it, because we've already set it up to bounce off of any line we give it there. So let hit line equal get hit line. So this is a little helper function that we need to create to get the line for the paddle. And so we can come up here, get hit line, and it should return an array of points. So it should return 2 vectors that represent the vertices of the hit line for that paddle. The thing is, this hit line is going to depend on which side we provided for the paddle, which side the hit line should be at. And we called that hit side. So if hit side is on the left, we need to return 1 array. else, if hit side equals right, we need to return a different array. I'm actually going to comment this out so that I can look at these paddles to help me figure this out. So if the hit side is on the left, so for player 2, then that means the line goes from the top left corner of the paddle to the bottom left corner. And the top left corner should be at x minus the width divided by 2 and y minus height over 2. And it goes down to the bottom left corner. So the bottom left corner is just going to be plus. So we're adding half the height there. That should work. We can copy this, paste it in here, and if it's on the right side, we need to add half the width to the center instead of subtracting. So this should be plus, this should be plus, and if we go down here, we can see if this actually works. So, does it bounce off the paddles? Oh, that looked like a bounce to me. Let's move the paddles around and see. Oh, yeah. Oh, yeah, this is super fun. This is looking pretty good. The ball is a little bit large, so let's change the radius of the ball. We had ball radius as 50. Let's change it to 20. That's more of a manageable ball size. Okay, and let's make it a little bit slower so that it's not so crazy. Maybe a little bit slower than that. Okay, so let's try this out here. That's looking pretty good. Oh, that's so satisfying. This is almost a game of Pong. Something we might have to do is, since our collision code actually moves the ball out of the overlap of the paddle, that should actually happen after the ball moves. So maybe I'm just going to put these two check hit functions beneath the move circle. And I think that'll work just a little bit better. Yeah, that's looking a little bit better. So we can just finish up this Pong game now. What we need to do is whenever the ball hits the edge, one of the edges, we need to score a point for player 1 or player 2. And then we need to restart the game. And we'll have it restart just setting the ball in the middle and having it be thrown in a random direction. So what we should do is in our check edge bounce, instead of having it reflect off of the sides of our canvas, we should have it track a point and then restart the game. So let's imagine we have a function and say that it score point. And we're going to tell it which player scores the point. So should it be player 1 or player 2? And let's just say, so if this condition happens, this is the right wall, So that means player 1 scores a point. So I'll put a little 1 there. And over here, this is going to be the left wall, and I'm going to put a 2 there. So if score point gets called with a 1, then player 1 gets a point. If it's 2, player 2 gets a point, and it restarts the game. So now we need to make that function. But before... So let's just make that score point player, and now our ball is bouncing off of into nowhere. Before we do that, we should create a scoreboard. I'm going to make a really quick scoreboard here. And the way I'm going to do that is create a div with an ID of scoreboard beneath the canvas. And I am going to create one box and call it score. One for player 1, one for player 2. We're going to need a label. Player 1. And we're going to need a score. Let's call this player 1 score. And we'll put a little 0 in there to start. And we can do exactly the same thing for player 2. Player 2 score. And you can barely see it, but there's some text here for player 1 and player 2. We're going to need to style that. So we're going to go into our CSS file. And we're going to set up a rule for the scoreboard. And we're going to use something called Flexbox to help us align things. It's just an easy way of dealing with alignment. And that is display flex. And we should make the font size huge and the color readable. Font size, let's make it, I don't know, 20 pixels? No, it should be way bigger. 80 pixels? No, too big. 50, let's say 40, okay? And color, start with white. And let's back it off a little bit. Let's go down to a very light gray for now. Next, we need to add a rule for the actual score, not scoreboard, scoreboard, and add a rule for each score. Let's align the text center. And we should set it so that the spacing for these has space around. And I think that's align items, space between. It's not align items, it's justify content. Okay. It's a little bit too big. We should set the scoreboard width to be 800 pixels. And I would like to have maybe a monospace font just to make it feel a little bit more gamey. So font, monospace. It should be font family. That's good. And let's make the actual score a little bit of a color. So let's do scoreboard, score. I'll tell you what, let's do it this way. We'll do a label with a certain color, which is this color. And other text can be, let's start with gold, and then we'll change it to something maybe like a light orange. Or maybe we should go computer green. I call this computer green for some reason. It's like we're in the Matrix or something. Anyway, you can set it to whatever colors you want. Have some fun with it. Now we have a scoreboard. We just need to change these values depending on the score. So in score point, what we can do is we can say if player is 1, we need to get the score for player 1. Else, if player equals 2, we get the score for player 2. So let's say I'm going to create I don't know why I put a semicolon. I never use semicolons. I'm not going to explain why here, but I never use them. We're going to create a variable for the HTML element that holds the score for player 1 or player 2. And if it's player 1, we're going to do the element equals document.getElementById player 1 score. Otherwise, it should be player 2 score. And now we just need to increment the value inside. So it should be L dot inner HTML is how you get the text inside of this element. So score should be this, and we need to make it an integer. Parse int, because it's going to be a string, so we need to parse it as an integer. Then we need to say score equals score plus 1. And then we need to set the inner HTML to the score. So it's working, but we need to restart the game. So let's pretend we have a restart function, and that should be called whenever score point is called. So now we need to create that function, restart. And restart should stop the ball. So we should say ball dot velocity set 0, 0. So it should freeze the ball. We should move the ball's position to the middle of the screen. So width over 2 and height over 2. There it is. And let's have it pause for like half a second or something, and then set it to a random velocity, like a serve, something like that. So what we can do is say set timeout, and we'll pass it a function. And after half a second, which is 500 milliseconds, we are going to set a random velocity for the ball, or not a random velocity, but a random direction. So we can do that by saying ball.velocity.randomize, and we'll give it a magnitude of 0.4. Nice. That's pretty good. And If it hits this wall, player 1 should score a point, and it does. So that's working really well. The last thing we need to do is we should call restart right after the animation, the animate call, so that it starts in the middle. And now we can set the paddles to be in the center. We could leave them at the top if we wanted, but I think we give the players a little bit more of a fair chance if we put them in the middle. So let's set why not for both of these to be height over 2. All right, and now I can play Pong with myself. Oh, this is so fun. I mean, the game Pong is not necessarily that fun, but I love building stuff like this. The fun part is tweaking it to exactly how you want it. So I would love to see what you come up with. If you've been following along with this tutorial and you have your own version of Pong, you can actually share it by going up here in CodePlay, hitting the share button and copying this link, and you can post it in the comments below. And I'd love to see what you all come up with, what kinds of colors you use, if you've added some tweaks to the physics or the simulation, or whatever. Share your CodePlay links in the comments, and maybe we can get some kind of discussion and help each other out and make some really awesome games of Pong. I'd like to do some other tutorials like this. I've had in mind to do a tutorial on building asteroids from scratch or almost from scratch, and building maybe some kind of platform game. And that way we can get into some more fun physics. Pong is pretty cool, but it doesn't have any gravity. It doesn't have any acceleration. If you'd like to see that, let me know. And if you have any suggestions for future episodes, please share your thoughts. Until then, have fun coding.